All right, hopefully everyone's back at the computer, ready to get going in a minute. We're going to be working in the PDF of YouTube questions and slides again, same as last time. And we'll start out, I think, about where we left off last time, working with some systems of equations, types of problems. So if you want to turn there, I'll obviously have it screen shared here. We are on page 87 of the PDF, and we'll start here with this question number 33. Let's take about another minute, and then we will start up. Today we're going to cover systems of equations. We'll move on to some linear models type questions, exponent and radical questions, some quadratics, and then I think we're going to do a little bit of SAT practice test number 7, the first math section in that one. So we'll see how far we get, but that is the plan for today. In the XY plane, the equations x plus 2y equals 10 and 3x plus 6y equals c represent the same line for some constant c. What is the value of c? So if we take these two equations, right, we have x plus 2y equals 10, and they give us this other equation, 3x plus 6y is equal to c. The question is, what is this value of c? The hint here is that they're the same line, right? In order to have the same line, we don't just need the same slope, we need the same slope and the same y-intercept. The equations need to be the same, right? We can't have, we could have two different types of the same equation to represent one line, but we need one equation to represent one line. So if we see between these two, there's a clear relationship, right? From x to 3x, we could get there by multiplying by 3. And from 2y to 6y, we could get there by multiplying by 3. So we're trying to find c, so we could take 10, what's in that same constant y-intercept spot, let's say, and multiply that by 3. Similar to what we did with elimination problems, right? We know we needed to modify one equation to make it compatible, in a sense, I guess, with the other equation. We can do the same thing here. So if we take this top equation, multiply it by 3, right, we're really just scaling it up. It's actually describing the same exact line. We're just scaling it up. So where are we at here? So if we multiply 3 times x, we get 3x. We multiply 3 times the 2y, we get plus 6y, and 3 times the 10, we get 30. As we can see now here, our 3x matches or 6y matches. So now the c is in the same point, or the same spot, let's say, same place as this 30. So c is our value for 30. Okay, let's move on to the next one. Number 88. Zoom in on this. It says a group of 202 people went on an overnight camping trip, taking 60 tents with them. Some of the tents held 2 people each, and the rest held 4 people each. Assuming all the tents were filled to capacity and every person got to sleep in a tent, exactly how many of the tents were 2-person tents? So, I mean, we know we're in the systems of equations section, so chances are we're going to need to set up a system of equations here. Obviously, on test day, you know, they don't tell you this will be the exact topic or idea tested here. Let's think about it here, right? We have a couple numbers, and we have some variables that we want to be able to coordinate with each other. So a group of 202 people went on an overnight camping trip, taking 60 tents with them. Some of the tents held 2 people each, and the rest held 4 people each. So let's define some variables here. They tell us we have 60 tents. We're taking 60 tents. Some of these tents are 2-person tents, and some of these tents are 4-person tents. So let's call X our 2-person tents. More specifically, the number of 2-person tents that we're taking. And we'll call Y our number of 4-person tents we're taking. We don't know how many we're taking so far. We're trying to find that out. So we need to set up some equations that we can kind of use with each other in conjunction to find our answer. So we have X, the number of 2-person tents, plus Y, the number of 4-person tents, that would be equal to the sum total of tents we have, right? We only have tents of the 2-person and 4-person variety, so this must be equal to our total number. So we have one equation now, x plus y is equal to 60. Second. X plus y is equal to 60. Okay. And they tell us that we have 202 people that went. So if we keep these same variables in play here, these x and y's, how can we involve that 202? Well, if we can fit 2 people in each 2-person tent, then the number of people we can fit in 2-person tents would be equal to 2, the number of people in each tent, times x, the number of those 2-people tents, 2-person tents, plus 4, the number of people that we can fit in a 4-person tent, times y, the number of 4-person tents we have. This would account for all the people that we have on this trip. So 202. So this is another system of equations that we have here, or another equation for our system. So we have 2x plus 4y. There we go. 2x plus 4y. Let me clean that up. Is equal to 202, the total number of people on our trips. Now we should be familiar with how to solve these. You could do substitution or you could do elimination, whatever one you think works best. And let's think about ultimately what we're looking to find here. It says exactly how many of the tents were 2-person tents. So we're looking to solve for x. So if we solve for x here, let me erase some of this, give me some room. Okay, so if we want to solve for x, what I'm going to do is cancel out these y terms. So I'm going to take my top equation here, x plus y is equal to 60, scale it up by -4, because I want that 4y term to cancel out. What will cancel with the 4y term? A -4y term. So multiply by -4. I'm going to rewrite this one down here. So instead of x, we now have -4x. Instead of y, we now have -4y. And 60 times -4 would be -240. My elimination, I can see these terms will cancel. 2x minus 4x would be -2x. 202 minus 240 would be -38. So solve for x, divide by -2, divide by -2, x is equal to 19. That makes sense. I have 19 2-person tents. If I wanted to check, right, I could say, if x is equal to 19, then here in this x plus y equals 60, I must have 41 tents, and then I could multiply, 4 people in 4 people in 4-person tents, 41 of them. Do the same for our x terms, 2 people in a 2-person tent times 19 tents, and it should add up to 202. They're just asking for the number of 2-person tents, so that's all we need to do there. Let's move on to number 90 here. I'm sorry, page 90, number 11. It says, in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? Let's take our equations. Let me rewrite them over here. I'm sorry, 1.75 plus. That the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So we can see here, we're starting out with like some y-intercepts with B, right, 2.35, and C, 1.75. And we can see that's eventually the price of chicken, C, will catch up to B, right? If you start out at week 0, let's say, then the price of beef is 2.35 and the price of chicken is 1.75. Eventually chicken will catch up because its slope, this 0.40x term, is greater than B. So eventually it will catch up. The way I can kind of think about doing this is that I can see that right off the bat, right? Like I said, if we plugged in 0 for X, the overall, or X equals 0, the overall difference right now between the price per pound of our beef and our chicken is 60, right? The difference between $2.35 and $1.75 is 60. The difference in our increase per week of each of these two is something about 0.15x, meaning chicken each week, the price of chicken will increase by 15 cents more than beef. So how many weeks would it take for these two to match? Well, how many weeks would it take for chicken, its price increasing at this greater rate, to catch up to 60? Well, we can just divide 0.60, set that equal to 0.15x. You know, 60 goes into, or 15 goes into 60 4 times. Same thing here with 0.6 and 0.15. X will be equal to 4. So after 4 weeks, they'll be equal to each other. But that's not the question. The question is, what is the price when they are finally equal to each other? So now we can just take this value for X, plug it into our beef equation. B is equal to 2.35 plus 0.25x. Here. 0.25 0.25x, we're going to plug in 4 for x. Sorry, I'm having some problems here with my Apple Pencil. There we go. Times 4, and solve for b. b is equal to 2.35 plus 0.25 is a fourth, times 4 will give us 1. So b will be equal to $3.35. See here, that is D. All right. So let's see here. Let's move on to linear models. So we're going to jump back. This will be on page 45 of the PDF. We'll go there now. Number 8 says the line y is equal to kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point C, comma D, where C is not equal to 0 and D is not equal to 0, what is the slope of the line in terms of C and D? So let's think about this here. We have this equation, y is equal to kx plus 4. We can see this is already in something resembling our y is equal to mx plus b form, right? So now we're trying to solve for k. K is essentially our slope in this point, right? It's in that m position. So how can we solve for the slope in terms of C and D? Well, we have this coordinate point, C comma D, and we can just plug these in like they're numbers. You know, it's kind of like a, it's a slope problem, but without actual digits, without actual values. We're just solving in terms of kind of abstract variables. So if I plug in C for my x and I plug in D for my y, I get, what are we at here? Get D is equal to C times x, so CX plus 4. Where are we at here? y is equal to kx plus 4, where k is a constant graph in the xy plane. If the line contains the point c comma d, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? We're going to solve for this x position here. So I'm going to get x by itself, subtract 4, d minus 4 is equal to c times x. I'll divide by c, divide by c, so my x term here now equal to d minus 4 divided by c. D minus 4 divided by c looks like a. Okay, that was page 46. 45, we'll move on to page 46. Next question, number 36. It says the linear function f is defined by f of x is equal to cx plus d, where c and d are constants. If f of 50 is equal to 27,000 and f of 100 is equal to 38,000, what is the value of c? Let's think about this here. Linear function defined by f of x is equal to cx plus d. And remember, I mean, it's written a little bit differently than our normal y is equal to mx plus b, but this term over here on the left, this f of x, it's really just holding the place of a normal y. And we can see this c here, right? It's just holding the place of a normal m, a normal value of the slope. So they give us 2 points. They tell us f of 50 is equal to 27,000. So really, that's just a coordinate, right? It's 50, comma 27,000. And when we plug in 50 for x, we get a value of 27,000 for y. And we have another coordinate, 100, comma 38,000. Ultimately, we're looking for the value of c. So let's see what we can do with these with this equation and these points. So let's take the first one and plug it in. So they say f of x is equal to cx plus d. We'll plug in 27,000 over here for f of x. Leave c. I'm going to plug in 50 for my x plus d. So if I rewrite this, just try to simplify this a little bit. 27,000 is equal to 50c plus d. All right, well, we can't really do anything there. We have an equation with 2 unknown variables. But what if we take this other one, 100, comma 38,000, and plug in here, do the same thing. I'm going to plug in my 38,000 for my f of x, so I have 38,000 is equal to c times x, so c times my 100 that I'm plugging in, plus d. Once again, I rewrite this. I have 38,000 is equal to 100c plus d. So I have 2 equations now. I have a system of equations. So I can just rewrite this in a way to solve for c. So now I'm just going to leave the 2 equations up that I want to use here. So that one on the bottom, I'll take this one here. So once again, I want to find c, so I want my d terms to cancel out. So both of the coefficients on these d terms are positive 1 right now, right? So if I'm going the elimination route, all I want to do is really just multiply one of them by negative 1. So I'll take the top one and multiply it by negative 1. So if I get that, I get negative 27,000 is equal to negative 50c minus d. And if I do the math there, I get 11,000 over here is equal to 50c. And my d terms cancel out. So now I can just solve for c, divide by 50, divide by 50. One of those zeros cancels out, so it's 1100 divided by 5. And depending on whether or not this is a calculator section, pretty easy division. I could even do this the long division route. $220 is my answer for C. Okay. That was page 46. I'll do a couple more in this section. 47 here, number 6. They give us a graph. It says in the XY plane above, line L is parallel to line K. What is the value of P? So we can see here, P describes the X value of this coordinate over here on this line K. They tell us, and this is vital to this question, that line L is parallel to line K. What does that mean? You can send this to me in the chat quickly. What does that enable us to do here in this problem? That line L is parallel to K. What piece of information does that tell us? Think about it in terms of slope. If we know they're parallel lines, what does that mean about their slope? Well, if they tell us that line L is parallel to line K, their slopes must be equal, right? So the slope of L must be equal to the slope of K. So we can't find the slope of K right now, but with with the values for line Y we're given, we can find the slope. We know M, our value for slope, is equal to Y2 minus Y1 over X2 minus X1. So we can plug this in. M is equal to Y2. So I'll call this top term my X2 comma Y2. Doesn't matter which way you subtract, you could do, or which one you call X2 Y2 versus X1 Y1. You just need to be consistent when you subtract them in your slope formula. So Y2 here for me is 2. My Y1 is 0. So 2 minus 0 over my X2, which is 0. Minus my X1, negative 5. So if I subtract a negative 5, I'm really adding 5. So I get 2 minus 0, 2 over 5. M is equal to 2/5. That's my slope. And once again, I know they're parallel. So the slope that I just found for line L is also the slope for my line K. So I'm just going to call this M, so K, my slope for line K. So I have, what am I at here? I have my points for P, 0, negative 4, and P, 0. I can use my point slope form equation. Y minus Y1 is equal to M times X minus X1 to solve for my equation of the line. If I plug in what I got here, it doesn't matter. Oops. Let me erase some of this here, give myself some room. So my slope was 2/5. Let me write that up here. 2/5. All right. Value of P we can see is the X term in that equation. So what I'm going to do is just get the equation of my line first using this given term down there at the bottom, and then go from there. So Y minus Y1 would be Y minus negative 4. So Y plus 4 is equal to M, which I know is 2/5. X minus my X term, 0. So I get Y plus 4 is equal to 2/5 X, or 2X over 5, however you want to write it. And then if I bring that over, my equation I can tell now is 2/5 X minus 4. Okay. Last step, just take this equation that we, or the coordinate that we want, P, 0. We're going to plug that in here and solve for P. So 0 is my y value. 0 is equal to 2/5 p minus 4. Add 4 over, I get 4 is equal to 2/5 p. To undo that 2/5, I can multiply by 5/2. Over here, multiply by 5/2. So p is equal to 20 over 2, which is equal to 10. That is my answer, D. All right. Next one, do one last one in this section. Down here on page 51, it's number 21. It says an equation of the graph shown is ax plus by is equal to 6, where a and b are constants. What is the value of b? So let's take that equation. Ax plus by is equal to 6. So I'm going to rewrite this here. By is equal to negative ax plus 6, just subtracting that over. I'm going to divide by b, just try and maybe make a little bit of sense out of this. So y is equal to negative a b x plus 6 over b. So given my graph here, I can see that I clearly intersect some points. I intersect here, so I intersect here, I intersect here and here. So if I look at this, I can see right here that this point is my y-intercept, right? I haven't moved off the x-axis, so my y value, my y-intercept, let me to not get confusing here, my y-intercept is equal to -2. And I can also get my slope out of this, right? So I can see that if I go from that point 0, -2, I go up 1 unit and over to the right 3. So my rise over my rise would be 1, and my run would be 3. So my slope here is 1/3. So that's my value for m. I have my y-intercept, I have my slope. So if I plug this into my normal y is equal to mx plus p formula, I know I have 1/3 x minus 2. But now I want it in this ax plus by is equal to some number formula. So I'm just going to bring this over. Put my x term first. So I'll subtract my y. So if I rewrite this, I get 2 is equal to 1/3 x minus y. I don't want any fractional exponents. I just want constants. If I scale this up here, so everything by 3. To get to that 6 value, 6 is equal to 1/3 x, just becomes x minus 3y. The coefficient on my y term is -3. That is answer A. All right, let's move on to another section. This will be a little bit newer, stuff we haven't done, or stuff we didn't do together last week. So look at this first one. A lot of the questions in this section follow suit here. Number 16, which of the following expressions is equivalent to x to the 2/3? So you have to remember here what these fractional exponents mean, what their implications are. So this top number in our fractional exponent, in this case our 2, is the number that we are raising x by, right? So normally in algebra, we might see some term like x squared or x to the third, right? X squared means we just have x times x. We know x to the third means we have x times x times x. That numerator is like the normal way we think about that exponent. But when we have a denominator here in our fractional exponent, in this case, this 3, we can rewrite this, and that's what we are taking the root of. So in this case, if that number is a 3, this means that we are taking the cubic root of x, but more specifically, we're taking the cubic root of x squared. So I can rewrite this just as my x squared term, right? Holding on to like this, holding on to what's in here. And now I can bring down this, bring down this x to the third term. I'm going to write that 3 in here. So I'm taking the cubic root of x squared. That's just a rewriting really of this form. And I can see that this answer here is k. So the denominator in our fractional exponent becomes what we're taking the root of in our radical. And then we can leave that numerator in that fractional exponent as our normal term there. So let's look at another one. 57 here, page 57, number 12. It says, which of the following is equivalent to 9 to the 3/4? So something should jump out to us about this 9, right? We know that 9 is not a fully simplified number. We could rewrite 9 in terms of exponents as 3/2, right? This 3 to the second. But that needs to be multiplied by this 3/4. So when I do that, I get 3 to the 2 times 3 is 6 over 4. I can simplify that fractional exponent. That becomes 3 to the 3/2. Let me write this here. Three to the 3/2. Once again, that top number means it's the amount of 3's I have. So in this case, I'm taking 3 and I'm cubing it, but I'm going to take the square root of that entire thing. And the square root, because the denominator in this fractional exponent is 2. So I'm taking the second root of my answer. So if I rewrite this, right, we know a normal square root or radical sign here with no number given implies the square root. But just to be clear, I'll write that 2 here. And then I have 3 to the 3rd. So I can just write 3 to the 3rd as 3 times 3 times 3. Right? I have 3 copies of my 3. So if we look at our answers, we can cross out A and B because that's a misplacing of those numbers. We're not taking the 3rd root, and we're not taking the 4th root. We're taking the square root. So in terms of the radical, it either would have to be C or D. If we think about how we can rewrite this number, 3 times 3 is 9, but I'm going to leave 1 copy of the 3 there. We can't take the square root of a 3, but we can take the square root of 9. So if I break this up into like 2 separate radicals, which you can, 3, I can see that that square root of 9 simplifies to just 3. So I have 3 times the square root of 3. That's your answer, D. All right, that's page 57. Do some more here. Page 58, next one. Says if x to the a squared over x to the b squared is equal to x to the 16th, x is greater than 1, and a plus b is equal to 2, what is the value of a minus b? All right, so a lot going on there. They give us a few conditions and a few equations that we can work with. Let's write down this first one here, x to the a squared over x to the b squared, and until that's equal to x to the 16th. So remember, when we have like terms or like bases in a fraction here, we can subtract our exponents in division, right? Multiplication of like bases means that we add the exponents. In this case, division means that we subtract. So our like terms here, or like bases, are x, both in the numerator and denominator. So I can pull out those terms. This means that I can rewrite this as x to the a squared minus b squared is equal to x to the 16th. They also tell me that I have a plus b is equal to 2. So if I look at that term, a squared minus b squared, I pull that out, set that equal to 16. I can see this is the difference of 2 squares, right? A plus b and a minus b is equal to 16. They do tell me that a plus b is equal to 2 up top. I could plug that in. right? They tell me this right here, a plus b is equal to 2. So I can swap out that term here for a 2. So I have 2, a minus b is equal to 16. And let's think about what the answer is asking. It says, what is the value of a minus b? So that's this term here. Right, that's this term here. So I just want to get that term by itself. So all I need to do now is just divide by 2. Divide by 2. Now my a minus b, I'll leave it in parentheses just to kind of show it as one distinct term, is equal to 16 divided by 2, 8. That is answer number A. Oops. Answer number A. Move on to the next one, page 59 of the PDF. It looks like we'll probably be working with some of these same things, subtracting exponents and a fraction, and looks like given by our answers some radicals here. The expression x to the negative second times y to the 1/2 over x to the 1/3 times y to the negative first, where x is greater than 1 and y is greater than 1, is equivalent to which of the following? Let's see what we got here. So we have x to the negative second times y to the 1/2 over x to the 1/3 times y to the negative first. So I'm probably going to want to start combining like terms, right? That would help me simplify this. So if I start out with my x terms, right? What I'll do is I'm going to subtract my numerator, or divide my numerator with my x's by my denominator. So if I divide x to the negative second, write this a little bit neater. If I divide x to the negative second by x to the 1/3, what I'm really doing is getting the result of x to the negative 2 minus 1/3. So it's x to the negative 2 minus 1/3. I want to simplify that, right? This negative 2 in terms of thirds would be negative 6/3 minus 1/3 gives me x to the negative 7/3. Kind of a strange number. Let's see what else we can do here. We have y to the 1/2 in my numerator, y to the negative 1 in my denominator. So once again, I'm going to do y to the 1/2, and it's going to be minus a negative 1. So I'm really adding 1 there. So I get y to the 3/2 now, and that should stick in my numerator. So if I rewrite this now simplified, I have x to the negative 7/3 times y to the 3/2. Let's look at this y term first here. This 3/2 is what we got last time, right? We had that 2 problems ago. We had this 3 to the 3/2 here. Right? So what ended up happening was that we wrote out 3 copies of that 3 inside our radical right here, and then we took the square root of it. So we knew 2 of those 3 ended up canceling out. So similar things should happen here with this y term. So if I'm going to rewrite this term here in more understandable terms, let's say, that's going to be the square root of y times y times y, which is the square root of y squared times y, which would just simplify to y times the square root of y. So I can substitute that in here, x to the negative 7/3 y times the square root of y. So let's look at which answers it can't be. Well, only really looks like it cancels out a. Let's see what we can do with this x term now. It's not right to have negative exponents, so to get rid of this negative 7/3, we want to flip that down to the denominator. So it'll change signs. So I have y times the square root of y over x to the 7/3. Once again, let's think about how we can break that up. So I'm going to leave my numerator intact. I times the square root of y. If I have x to the 7/3, right? That's the same as me saying I have the cubic root. Again, that denominator in the fractional exponent becomes the root that we're looking for of this term. And I'm going to break this x to the 7th up into chunks that would work with this cubic root. So things that we'd be able to take the cubic root of would be x to the 3rd. Write another x to the 3rd. I'm going to break it up as x to the 1st, right? Because all those exponents, 3 plus 3 plus 1, add up to that 7 that we had. So if I take the cubic root of x to the 3rd, I get x. I take the cubic root of another x to the 3rd, I get another x. So I'm going to have an x squared out here. And then whatever's left, I have the cubic root of x to the 1st. So this is what should be my denominator. So if I merge these terms, right, I take my numerator there, and now this rewritten denominator. Just happened. I want y to the square root of y over x squared times the cubic root of x. I can see that's this answer here. This doesn't have an x, a cubic root radical there. B does, but it's not written properly. So D is our answer there. Let's see here. What are all the values of x that satisfy the equation above? So let's write what we got. X squared minus 1 over x minus 1 is equal to -2. That numerator should look manageable, or let's say somewhat familiar to us. It's a difference of 2 squares, right? I can rewrite x squared minus 1 as x plus 1 times x minus 1 over x minus 1. Those x minus 1 terms cancel out. That's equal to 2. So I have x plus 1 is equal to 2. X plus 1, x minus 1, x minus 1's cancel, right? X plus 1, I'm sorry, is equal to -2. Be careful there. So if I subtract that one, x is equal to -3. That's one potential solution. So I can see clearly it can't be B or C. Question says, what are all the values of x that satisfy the equation above? So I know -3 must be one of my answers, but I can see here in answer D, could -1 be a potential answer here? Well, let's plug it in and see what would happen. We should see clearly here in this term, right, this x plus 1 term, that if I plug in, talking about this term here, if I plug in a -1 there, I'm going to get a 0 up top, right? And a 0 all the way over there on the left side, no way, it can't equal -2. It's not possible. So D is not a possible answer. A is my answer. All right. Let's see what else we got here. It's another good one. A little bit more confusing exponents, but it'll get those skills a little bit stronger. So it says, which of the following is equal to 9 to the 5/4? So we have 9 to the 5/4. Just like we did maybe in one of those first or second radical type problems here, right? We want to consider that 9 term in a more simplified base. So we know that 9, and technically it's 9 to the 1st, is equal to 3 squared. So if I substitute that in here, I get 3 squared. It's going to be times 5/4. Let me rewrite that. 2 times 5 is 10 over 4. That's a pretty crazy fractional exponent. I'd really rather not start writing out how many copies of 3 I have there, and then find the 4th root. So I can simplify that. I can see that 10 to the 4th can simplify, right? 10 to the 4th, 10 over 4, I'm sorry, simplifies as 5/2. So this is really 3 to the 5/2. So I know that 2 in the denominator means I'm taking the square root of 3 to the 5th. So I'm taking the square root of 3 to the 5th. I want to think about this. How can I write out copies, let's say, of this 3 term that would be compatible with the square root? Well, I could do 3 squared times 3 squared times 3 to the 1st, right? 2 plus 2 plus 1, that takes care of all of these copies of 3 that I have. I can find the square root of 3 squared, which would just be 3. It takes care of that one. Find the square root of this 3 squared, that takes care of that one. And then what's left would be 3 to the 1st, right? I can't find the square root of that, so I'm just going to leave it as square root of 3. So I get 9 times the square root of 3. That's the best simplified form of that. So let's move on here. Let's look at number 20 here on page 65. So it says if u plus t is equal to 5 and u minus t is equal to 2, what is the value of u minus t times u squared minus t squared? It's kind of a strange problem, right? Why are they giving us these two equations, u plus t is equal to 5 and u minus 2 is equal to 2? What can we really do with that? Well, let's write this out. We can see, it should be u minus t. We can see that this term here, u minus t, is that, and we give a value, they give us a value of that of 2. So we could substitute in that in there. And this u squared minus t squared term is a difference of 2 squares, and we have the 2 components of that difference of 2 squares, u plus t and u minus t. So let me rewrite this. U minus t, that difference of 2 squares can be written as u plus t and u minus t. So I have everything I need. If I take that u plus t here, that's a value of 5. I'm going to plug that in here. And then I have this u minus t value of 2. I'm going to plug that in here and here. It just becomes like a 3-factor multiplication problem, right? So u minus t is equal to 2. So it's going to be 2 times u plus t, which is equal to 5. And u minus t, which is equal to 2. So 2 times 5 is 10, times 2 is equal to 20. That's my answer. That's right. And on approach to that problem, it looks kind of intimidating or kind of strange in a sense, right? But they want you to think, and they want you to be able to identify instantly that this term here is a difference of 2 squares, and then that opens the door really to the rest of the problem. Let's see. Yeah, we'll do one more here in this section, and then we'll move on. So page 66, number 5. It says in the equation above, k is a constant. If x is equal to 9, what is the value of k? So really here, just solving for k. So we have the k plus 2, the square root of that, minus x is equal to 0. They tell us that x is equal to 9, so might as well plug that in now. K plus 2 minus 9 is equal to 0. Let's undo that square root, undo that radical. We're probably going to want to square it, but let's not get 9 involved. So let's add, or this subtraction of 9. So let's add 9 over. We get the square root of k plus 2 is equal to 9. Squared, undoes the radical. We get k plus 2 is equal to 9 squared, which is 81. Subtract 2, subtract 2, subtract 2. K is equal to 79. That is answer D. All right. Let's move down. New section, like I said, we might jump into practice test number 7, the same practice test we're working with Mr. Scotty on, just do the math section. Let's look here. What question did I want to do? Let's start here. Page 113, number 42. It says given f of x is equal to x minus 1 over x, and g of x is equal to 1 over x, what is f of g of 1/2? So if you look at this term here, they want us to find the solution of f of something, but the f of whatever it is embedded in something else. So to start, we need to find what g of 1/2 is equal to. To find that, we just plug 1/2 into our g of x equation. So here, g of 1/2 will be equal to 1 over 1/2, which is equal to 2, right? 1 divided by 1/2 is the same thing as multiplying by its reciprocal. So 1 times the reciprocal of 1/2 is 2. 1 times 2 is 2. So g of 1/2 is equal to 2. So what we're doing now is finding f of 2. So now I need my f equation. It says given f of x is equal to x minus 1 over x. So f of 2 will be equal to 2 minus 1 over 2. Solving for that, 2 in terms of halves would be 4/2 minus 1/2 give me 3/2. That is my answer. That is K. Let's look here, page 117, number 10. It says the graph of y is equal to 2x squared plus 10x plus 12 is shown. If the graph crosses the y-axis at the point 0, k, what is the value of k? All right, so if we look at our graph here, we can see k is right here, and they tell us it crosses the y-axis, right? That's a y-intercept. It's the point where we haven't moved off the x-axis, and that makes sense because we have this point 0, k. Our x value better be 0. So we're solving for k. K is really just the y term in that coordinate. So if we plug in 0 here as our x term into this equation, out will come the k value. I have y is equal to 2x squared plus 10x plus 12. I'm plugging in this coordinate 0, k. K now becomes my y value, so k is equal to 2 times 0 squared plus 10 times 0 plus 12. Let me rewrite that a little bit here. So 0 squared will make that whole term 0. 10 times 0 will make that whole term 0. So the only thing that's left is 12. So k is equal to 12. That's my answer, D, and that will complete that point, make that point 0, 12. All right. Let's look here. Pretty simple one. It says the graph of y is equal to f of x is shown in the xy plane. What is the value of f of 0? Once again, remember that f of 0, they're just telling us plug in 0 for x. So if we plug in a 0 for x here, what do we get? Well, if we look at this graphically, right, the point where our x term is equal to, where our x value is equal to 0, right, would be right here along the y-axis. We can clearly see that the graph intercepts this point right there. The graph intercepts the y-axis at that point. That point is 0, 4, right? And they're asking, what is the value of f of 0? Well, it's 4. It's the y term, or the y value there. So that is D. Let's do this one to end. This is a pretty simple quadratic one. So we have f of x is equal to x squared minus 2x plus 4. They want us to find f of -3. So all we have to do is plug in -3 here, right, to solve for f of -3 x squared. So -3 squared minus 2x, so it's going to be minus 2 times -3 plus 4. Simplify this. Negative 3 squared gives us 9, minus 2 times negative 3. 2 times negative 3 would be negative 6, but minus negative 6 would just give us positive 6 plus 4. Simplify. F of negative 3 is equal to 9 plus 6 plus 14 gives us 19. So F of negative 3 is 19. That is answer A. So I'm going to jump over to SAT practice test number 7. This should be the one that you were working with Mr. Scotty earlier on. And we'll jump to the math section, which is the third section here. Right here, starts on page 36 of the PDF. So I'll give you a couple seconds if you want to open that up on your end. So let's start here on page 37 of the PDF. We'll start with number 1. Give you a couple more seconds if you want to turn to that. I'll try and fit my work here in the space. All right. It says the equation above relates the number of minutes X Maria spends running each day and the number of minutes Y she spends biking each day. In the equation, what does the number 75 represent? So if you think about this equation that they give us here, X plus Y is equal to 75, right? They tell us X term is number of, let's say, running minutes, or minutes running, I guess would be a better way to word that, number of minutes running. And this Y term would be the number of biking. So this X plus Y must be the sum total of it. It's the total number of minutes she runs plus the total number of minutes she bikes. So let's look at the answers here. A, the number of minutes spent running each day. No, that can't be right because it also factors in Y, so that's not right. B, the number of minutes spent biking each day. Same answer, really, just kind of now focused on Y. That can't be right. It ignores the time spent running. C, the total number of minutes spent running and biking each day. That sounds right. So let's pull a check mark there. And then D, the number of minutes spent biking for each minute spent running. Number of minutes spent biking for each minute spent running, that would kind of imply some ratio or fraction. So no, that's not right. It's just the sum total. So total, so giveaway here, C is our answer. Let's jump to number 2. Which of the following is equivalent to 3 times the sum of X plus 5 minus 6? Well, pretty straightforward. We're going to distribute this 3. So 3 gets distributed to the X, we get 3X. 3 gets distributed to 5, we get plus 15. Then we have minus 6. The 3X term can stay. Clearly, it's not going to be D. Our only X term here is 3X. 15 minus 6 gives us a remainder of positive 9. So 3X plus 9, not B, not A. Answer is C. All right. Number 3 here. Which ordered pair, X comma Y, satisfies the system of equations above? So the other way sometimes this is worded is, what is the solution of this system of equations? Remember that we have a system of equations where they're giving us 2 lines essentially, and the solution, the answer really, is just where they intersect. That's the same thing here. And if we think about it, that makes sense. The ordered pair should be exactly where it is on a graph if we were to plot these 2 things, where they would intersect. So which ordered pair XY satisfies the system of equations shown above? Well, like I said, for system of equations, your 2 options really are either substitution or elimination. To me, I like substitution here because I have this X term by itself in this equation, and that would work nicely to plug right into here. So let's do that. If I take that X is equal to Y minus 3 and plug that into the numerator of that second equation, right? I'm saying that X is equal to Y minus 3, so I can rewrite that as Y minus 3 over 2 plus 2Y is equal to 6. I'm going to multiply everything by 2 just to undo that. So multiply by 2 there. I'm going to need to multiply this by 2 and multiply this by 2. So my remainder is y minus 3 plus 4y is equal to 12. Combine those y terms, I get 5y minus 3 is equal to 12. Add that 3 over. 5y is equal to 15. Y divided by 5 must be equal to 3. If I look at my answers, the only one that has y has a value of 3 is B, so that must be my answer. Let's go through, though, and check what our value for x should be. We're saying now that our x must be equal to 0, just to be sure, because you might not have substituted in the way I did. So let's double check this. So now that y is equal to 3, I want to solve for my x term. And to me, is the easiest way to solve for my x term would be to plug this y equals 3 term, y is equal to 3 value, right into this equation. X is equal to y minus 3. Plug in a 3. I get x is equal to 3 minus 3. Yep, x is equal to 0. That's true. That makes sense. B is your answer. Number 4. Which of the following complex numbers is equal to 5 plus 12i minus 9i squared minus 6i for I is equal to -1, the square root of -1. So our imaginary numbers, right, we should have a couple memorized. We know that I really can't be written any other way. Let's start here. I to the 0, anything to the 0 is 1. I to the first is just I squared. And they're also telling us that it's the square root of -1. So I squared then must be -1. I cubed would be, I cubed would be I times I squared, so -1 times the square root of -1. Let's just call it -I. That's a better way to think about it. And then I to the 4th would give us I. So let's put that to the side here. Let's look at the question. Which of the complex numbers is equal to this? So we want to rewrite this. We have a difference here, though, these products, of these parentheses here. So this subtraction sign means that this should be negative, but this should be positive. So let's just rewrite this. We have 5 plus 12i minus 9i squared plus 6i. Let's combine like terms here. We get 5. Those I terms can combine 12i and 6i. We get 18i. I have now a minus 9i squared. All right, so if I look at all my answers, they all have an I term in them, right? And I to the first term. So I know some things that I is equal to over here on the right, and they tell us that I is equal to the square root of -1. But all of our answers leave those I terms there. So I want my answer to make sense and kind of align with that. So let's leave that I term by itself. Let's not incorporate numbers that we know for I here, but let's take this 9i squared term, this -9i squared term. If we look just at what they give us, I is equal to the square root of -1. We want to do away with this I squared term. So we just need to find what I squared is equal to. So if I square this, I need to square this. I squared then becomes equal to the square root of -1 squared, which is just -1. So I can plug that in here. So 5 plus 18i minus 9i squared. This is minus 9 times -1. Not squaring that term. The i's and 1's are all looking the same to me. 5 plus 18i plus 9. Add the 5 and 9. That's 14 plus 18i. That's my answer. D. All right. Let's move on to the next page here. We got about 15-ish minutes left. Let's see how far we can get. All right, number 5. If f of x is equal to x squared minus 6x plus 3 over x minus 1, what is f of negative 1? Pretty straightforward. We just need to plug in negative 1 for our x squared terms here. So f of our x terms, we get negative 1 squared minus 6 times negative 1 plus 3 over x minus 1, so negative 1 minus 1. So f of negative 1, let's simplify this. Negative 1 squared would just be 1. Minus 6 times negative 1 would be plus 6 plus 3. Negative 1 minus 1 would give me negative 2. Let's combine these terms. 1 plus 6 is 7, plus 3 is 10. Divided by negative 2 gives me negative 5. That is answer A. Okay, number 6. Excuse me. A company that makes wildlife videos purchases camera equipment for $32,400. The equipment depreciates in value at a constant rate for 12 years, after which it is considered to have no monetary value. How much is the camera equipment worth 4 years after it's purchased? So if we think about this camera equipment, brand new, total cost of it is $32,400. Depreciates in value for 12 years, and at the 12th year, it has no monetary value. So at 12 years, its value is 0. So we can assume that it should depreciate a constant rate over these each of these 12 years. So if I think about a way to write this, $32,400 would be my starting amount, right? That's I'm not going to have more worth than that, but every little bit, every dollar of that is slowly going to drop as I go. It's going to decrease in some relation to time, and we want to find out how much it drops each year. So we know overall it's going to be equal to $0 at the end of 12 years. So if I subtract minus 12 years times x, and x here is signifying the amount of money it depreciates by each year. I can find what that value is for x. And then the question is saying, how much is the equipment worth after 4 years? Well, if I can find out how much it loses within 1 year, I can multiply that by 4 and then take that away from my original. So let's solve for x here. 32,400 minus 12x is equal to 0. I'm going to add 12x over. So my equation is now 12x is equal to $32,400. Going to divide by 12. Probably want to do this with a calculator. Yeah, I can do this in my head. You can do this long division too. These numbers should be, say, pretty friendly to work with. 32,400, dividing that by 12. 12 gives me 32 2 times, 24. Remainder of 8, bring that up. How many times does 12 go into 84? 7 times. 84, 0, 0, 0. So $2,700 is the amount that it depreciates each year by. The question is, how much is it worth 4 years after it's purchased? So let's take this equation that we originally wrote, But we don't want 12 years, right? If you multiply 12 years by the amount it depreciates by each year, it would be 0. We want 4 years. So let's rewrite this equation. $32,400 minus 4 years times the amount it depreciates by each year, $2,700. And we're solving for what that's equal to. Right, looking for that answer. So let's do that. $32,400. 4 times 2,700, that should be 10,800. Let me just check that. So you should have it. Oh, wait, I'm sorry. This is a non-calculator section. So no, I'll do it the long way then. 2,700 times 4. I do know 27 times 4 is 25 times 4 is 100. And then 2 more times 4 would be 8. So it should be 108. Add 2 zeros. But if I'm going to do this the long way, 0, 0. 4 times 7 is 28. Add 2 here. 2 times 4 is 8. Plus that extra 2 gives me 10. 10,800. Minus 10,800 is equal to what? Well, we got to do some subtraction here. $21,600 is our answer. And that is answer C. All right. Let's keep rocking. We got about 10 minutes left. Let's finish strong here. That's a long day of SAT prep, but all worth it. It's going to get us some better scores. So we have number 7 here, x squared plus 6x plus 4. And the question says, which of the following is equivalent to the expression above? So let's look at these terms, right? They all have some x and then either plus or minus 3 term in parentheses, and we're squaring them. What we're doing here is completing the square. If we remember our procedure for completing the square, let me bring down this, x squared plus 6x plus 4. I want to use my first 2 terms, my x squared term and my x to the first term, to guide what that third term should be. So let me take an example here. If I have let's say I have x plus 2 squared. Once again, this is just an example to kind of refresh you about completing the square. The short way of doing this, right, is I can square the first term, so I get x squared. I'm going to take the product of the inner 2 terms. So x times 2 would be 2x. I'm going to double it, plus 4x, and then square the second term, 4. So if I think about that, right, I doubled the product of these 2 inner terms to get 4x, right? So if I think about what that number is here, it's 6x, right? So if I take half of that, remove the x from it, it's 3. That's that second number here. In our one, it's not 2 that we want, but it's 3. So how can we do this here? I mean, that makes sense, right? That makes sense here, 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 right? We know there's a difference between minus and or positive and negative signs here, but we can figure that out. So let me clear this here. So again, we said that 3 term here, that 3 term that's present as the second term in all of our parentheses here, that's that term that we're going to square. If we square that 3, we should get a 9. But here we have a 4. So we want to rewrite this 4 term in some way that we can get a 9 out of it. It's kind of a weird thing to think about in math. You know, we're going to unsimplifying this number, right? We have 4. That's too simple. We want a number that works for us here. So we want 9. How can we rewrite 4? That is true to say that it could be 9. So x squared plus 6x, well, 9 plus 9 minus 5, right? 9 minus 5 is equal to 4. And this is true. I didn't violate any rules here. This makes sense. 9 minus 5 is positive 4, so I can leave this how it is. But when I go to complete the square, I only want to hold on to the terms that make sense for me completing the square. So that's where I draw that line here, right? So if I take the, if I factor this here, I should have x plus 3, and that's going to be squared. Leave out that minus 5 term. This is what I get. And that is answer B. This is wrong because it's not minus within the parentheses, and it's also not plus 5, it's minus 5. So B is the correct answer here. Let's look at this last question here, number 8, and then we will call it a day. What does it say? Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves 90% of his earnings from each week. What is the least number of hours he must work for the rest of the week to save at least $270? What is the least number of hours he must work for the rest of the week to save at least $270 for the rest of the week? Okay, so he's being paid 2 different rates, right? He's being paid $8 per hour for the first 10 hours, and then his salary goes up, or his hourly rate goes up to $10 per hour. So clearly, to get to $270 for the week, right, he needs to be working more than 10 hours. So he's going to exceed this $10 per hour wage, right? So $8 per hour times 10 hours would give us $80. So he hits the max on that part of his wage, let's say. And then the rest of that money needs to come from this $10 per hour work. But we also have to take into account that he is only saving 90% of his earnings, right? So let's make an equation for the sum total of how much he works, or how much money he can derive, let's say, from his work. So we have this $80. That's kind of set, right? We know he's clearly going to exceed 10 hours of work. So we have $80 plus, let's think about this, $10 per hour for each hour for the rest of the week beyond that first 10 hours. So it's going to be $10 times the amount of hours he works beyond that times X. And we think about this, once again, X, these are the number of hours beyond those 10 hours. So let's see here. We have $80 plus 10X. Once again, he's only saving 90% of it, so he's not really getting the sum total of 80 plus 10X. He's only getting 90% of it, right? 90% of his earnings. 90%, we don't want to involve percentages in our math. We should change that to a decimal, so 0.9. So 0.9 of this. And he wants to save at least $270. So the right way to write that is as an inequality, and that will be greater than or equal to, right? He wants the bare minimum to be $270. He needs to at least cross that threshold. So now let's solve for this. We want to solve for X. So we're going to divide by 0.9, divide by 0.9. Right, don't let this intimidate you. 270 divided by 0.9. We know 27 and 9 are compatible, right? So this is just 27 times 10 divided by 0.9, or I could say 0.9 times 0.1. 9 times 0.1. I'm doing this because I believe this is the no calculator section, right? Yep, no calculator, so we want to be able to work with these numbers in our head. So 27 divided by 9 would be 3, but that's going to be 3 times 10 over 0.1. 3 times 10 will be 30, divided by 0.1 will give us 300. we get 80 plus 10x is equal to 300. We're going to subtract that 80. Now it's 12 o'clock now. We're just about done. 10x is equal to 220. Divide by 10. X is equal to 22. That is answer C. And that makes sense, right? These are the hours he works beyond those first 10 hours at that lower wage. All right, so we'll stop there for today. Please be sure to finish up practice test number 7 for your homework. That's really important. You know, it's good that we're coming each Saturday to do this work here, but you know, your all the practice that you did today will really be much more strongly solidified if you follow it up this week with additional practice. So good job today. That's a long section. That's a lot of questions, a lot of math and reading. But we'll see you all back here next week.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.